Many a woodworker has stood in their shop, a beautiful piece of walnut in one hand and an expensive saw humming nearby, only to end up with a cut that is just off. You might blame the wood, or maybe think the blade is getting dull. You spent a pretty penny on that saw, a tool that promised perfect 90-degree angles and cuts as straight as a sunbeam. Yet, the results are frustratingly inconsistent. Your joints have gaps you could drive a truck through, and your tabletops refuse to lie flat. This isn't because you lack skill or passion. The problem is often invisible, a gremlin hiding in plain sight. It's the accumulation of tiny, almost imperceptible errors that compound with every single cut you make. We often reach for the tools we know best, the familiar friends of the workshop. A trusty tape measure, its metal tongue scarred from years of service, seems like the pinnacle of accuracy. We pull it taut and mark our line with a pencil. Then we might grab a plastic or aluminum combination square to check for a right angle, trusting its factory-molded edge. But here's the hard truth. For the kind of precision that separates good woodworking from masterful craftsmanship, these tools are simply not enough. A tape measure's hook can shift, its markings can be thick, and your own eye might introduce a tiny bit of parallax error. It's a game of approximations. Think about it this way. A hairline gap of just 1/100th of an inch might seem insignificant on a single board. You can barely see it. But what happens when you glue up 8 of those boards to make a tabletop? That tiny error multiplies. Suddenly, you have a gap wide enough to lose a nickel in. Your project is compromised before you even get to the sanding. Those common measuring tools are great for rough framing a house, where close enough is often good enough. But, in the world of fine furniture, where joinery must be airtight and surfaces flawlessly flat, close enough is the enemy of excellence. It's the source of endless frustration. This is where we need to change our thinking. We must graduate from the world of estimation to the world of true measurement. The tools that build a deck are not the same tools that build a Stradivarius violin. To achieve the kind of results you see in fine furniture galleries, you need to adopt a tool from a different discipline altogether. It's time to look beyond the woodworking aisle and borrow a secret weapon from the world of machinists. A world where tolerances are not measured in fractions of an inch, but in thousandths. This shift in mindset is the first and most crucial step toward taking complete control over your craft and leaving guesswork behind for good. Let me introduce you to your new best friend, the machinist's dial indicator. This isn't a tool for measuring the length of a board. Instead, it's a device designed to measure incredibly small movements or variations on a surface. Imagine a highly sensitive mechanical finger that can feel changes in height so tiny that your own fingertips would never notice them. That is essentially what a dial indicator does. It translates these microscopic physical movements into a clear, easy-to-read measurement on a clock-like face, or dial. When you need to know if a surface is perfectly flat or if a spinning blade is wobbling by a hair's breadth, this is the tool that gives you the definitive answer. The tool itself is a marvel of simple mechanics. It consists of a body, a plunger or stylus that sticks out from one end, and the circular dial with a needle. As the plunger is pushed in or released, a series of internal gears and levers magnifies that tiny movement, causing the needle on the dial to sweep around. Each marking on the dial typically represents 1/1000th of an inch. Some are even more precise. This means you are no longer guessing based on a pencil line. You are reading an exact quantifiable measurement. It's the difference between saying that looks about right and knowing with absolute certainty that it is right. Now let's compare that to our old standbys. A standard ruler or tape measure is usually marked down to 1/16th of an inch. If you're lucky, you might have one with 30 seconds. 1/16th of an inch is about 0.0625 inches. The dial indicator is measuring in increments of 0.001 inches. That means it is over 60 times more precise than the finest mark on your tape measure. It operates on a level of accuracy that is simply impossible to achieve with the naked eye or standard woodworking squares. Using a tape measure for machine calibration is like trying to perform surgery with a butter knife. It's the wrong tool for a delicate job. To use this tool effectively, you must remove the biggest source of error: your own unsteady hands. That's why a dial indicator is almost always used with a magnetic base or mounted in a purpose-built jig. The magnetic base has a powerful switchable magnet that locks the entire assembly firmly onto any cast iron or steel surface, like your table saw's top. An articulated arm, allows you to position the indicator's plunger precisely where you need it, and it will stay there, solid as a rock. This ensures that the only movement being measured is from your machine or workpiece, not from you. It's this combination of stability and sensitivity that unlocks a new realm of precision. The table saw is the heart of most workshops, and it's the first place you should put your dial indicator to work. One of the most common problems woodworkers face is blade burn or kickback, often blamed on a dull blade. While that can be a cause, the real culprit is frequently a misaligned blade or fence. First, let's check if the blade is running true. With the saw unplugged, mount your dial indicator's magnetic base to the tabletop. Position the plunger against the side of the saw blade, near the front teeth. Zero out the dial, then slowly rotate the blade by hand. Watch the needle. If it flickers more than a couple of thousandths, your blade might be warped. Next, we check for something called arbor runout. The arbor is the shaft that the blade spins on. If the arbor itself wobbles, no blade, no matter how perfect, will ever cut straight. To check this, remove the blade. Position the indicator's plunger directly against the smooth, machined face of the arbor flange, the big washer the blade sits against. Again, zero the dial and rotate the arbor by hand. If the needle moves more than 1/1000th of an inch, you have a mechanical issue with your saw's bearings or arbor shaft. This is crucial information. It tells you the problem isn't your technique, but the machine itself. Knowing this saves you from a lifetime of fighting a tool that can't be fixed with a simple adjustment. Now, for the most important table saw calibration, aligning the rip fence parallel to the blade. A fence that isn't parallel will pinch the wood against the back of the blade, causing burning and dangerous kickback. To fix this, clamp a straight piece of wood or a metal bar into your miter slot. Mount your dial indicator to this bar and position the plunger against the rip fence near the front of the saw. Zero the dial. Now, slide the entire assembly to the back of the saw. Does the needle move? If it does, your fence is not parallel. You can now make tiny adjustments to the fence and watch the dial in real time until it reads zero at both the front and the back. This process transforms your table saw from a source of frustration into a machine of surgical precision. Once your fence is perfectly parallel to the blade, or set with a tiny bit of clearance at the back, as some prefer, your cuts will be effortlessly straight. The wood will glide through the blade with less resistance. You'll eliminate burning on your rip cuts. Most importantly, you will have created a reliable, repeatable setup. Every piece you cut will be exactly the dimension you intended, which is the foundation for all high-quality joinery and assembly. This is how you take control of your machine and make it work for you, not against you. The dial indicator's usefulness extends far beyond the table saw. Consider your jointer, a machine whose entire purpose is to create dead flat surfaces. You can use the indicator to set the height of your outfeed table relative to the knives with incredible accuracy. By running the indicator across the cutter head from the infeed to the outfeed table, you can adjust the outfeed height until the needle shows zero deviation as a knife passes its highest point. This eliminates the snipe and tapered cuts that plague so many joiner users, giving you perfectly flat boards every time. The same principle applies to setting individual joiner knives to be perfectly level with each other. Even a drill press can benefit. Have you ever drilled a hole and found it was slightly oversized? That could be due to runout in the chuck. You can mount your indicator to the drill press table and place the plunger against a smooth drill bit or steel rod held in the chuck. Rotating the chuck by hand will reveal any wobble, telling you if your chuck needs cleaning or replacing. You can also use the indicator to ensure your drill press table is perfectly perpendicular to the spindle, which is critical for accurate drilling, especially when using Forstner bits or hole saws for fine furniture work. It's about diagnosing and fixing problems at their source. Beyond machine setup, a dial indicator can even serve as an early warning system for your materials. Wood moves. It cups, bows, and twists with changes in humidity. Before you commit a beautiful, expensive slab of wood to a project, you can check its flatness over a few days. Place the board on a known flat surface, like your newly tuned table saw top, and set up your indicator. By measuring it today and again in a day or two, you can quantify how much that board is moving. This knowledge can save you from building a project that tears itself apart later. It's proactive craftsmanship, not reactive repair work. Ultimately, adopting the dial indicator is about a fundamental shift in your approach to woodworking. It's about moving from a world of guessing and good enough to a world of knowing and perfect. It saves you money by reducing wasted wood from bad cuts. It saves you time by eliminating the need to recut and fix mistakes. More than anything, it builds confidence. When you know your machines are tuned to within a thousandth of an inch, you can focus on design and execution, secure in the knowledge that your tools will perform exactly as you command. You stop being just a woodworker and become a true craftsperson, a master of your tools and your material.